maybe you should have gotten something out of it, like converting to electricity. That's a discussion.
That's
where
a
did all the money go?
idea.
Right? Well, yeah. Where did all the money go?
Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the UPTIME podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the UPTIME Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, we'll do some predictions towards the end, but first we're going to talk about Ørsted, interesting partnership with Maersk. We'll talk about the Sun Cable project that's looking pretty interesting, got a big round of funding recently. Talk about some new engineering, a flapping small wind turbine that might catch on, we'll see. And then we'll jump into sanctions, inflation, all these other predictions about all the crazy stuff that's happening in the world right now. So, Alan, let's first start with this interesting partnership between Ørsted and Maersk. They're looking to sort of, I guess, pioneer some uncharted water into green fuels. And it looks like eMethanol is where they're going here. What does that mean, Alan?
eMethanol is a created molecule of methanol that uses clean sources. So it sounds like they're going to strip carbon from the atmosphere, use the carbon, also create hydrogen from water, more than likely. So you got these carbon molecules, you got these hydrogen molecules, and if you combine them in a certain way, you can create methanol, or what they call eMethanol. So what Ørsted plans to do is, and Maersk plan to do, is power methanol ships. So they have a green ship, and Maersk has ordered several ships, maybe a dozen ships like this to do these routes. So we can clean ship product from China to the United States to Europe, wherever it has to go in a green way. And maybe there's other technologies here, but this seems like a very complicated way to make fuel to power ships. But this power to X is part of this power to X exercise that's happening in Europe and now in the United States, where they're trying to create renewable liquid fuels from the atmosphere. We talked about Airbus doing it for airplanes and actually having a hydrogen-powered airplane using green hydrogen. And there's discussions with that's happening in the United States also, with GE and Boeing are doing similar things. So it looks like that's expanding out to other forms of transportation where we're using or creating liquid energy molecules, I'll call them, to power transportation. It's an interesting concept. I just kind of wonder, Dan, if it's worth it financially to do that, unless you have big donors like an Amazon that can afford it, because it's got to be a lot more expensive than buying sort of diesel fuel that's used in ships today.
Well, eMethanol, I guess, is the preferred, like the main green source of fuel that shipping can switch to right now. It definitely still creates some greenhouse emissions, but less gases than others, less carbon dioxide, less nitrogen oxides, less sulfur oxide. So it looks like a step up, but I don't know. I mean, Alan, is this like the next logical step between what we're currently burning for shipping versus an electric ship? I mean, is an electric ship even realistic, or is that way too far off?
Way too far off. You don't have the battery technologies to make a truly battery-powered ship. But you have those shipping rules that are kicking in, I think in 2023 or 2024, where they have to reduce the emissions by like 30%. Well, the way that most shipping routes happen today, if you have an existing ship, you just got to slow it down. So it's going to take longer to ship product from U.S. to Europe, for example. So it's probably going to add another 30% on time to get from A to B. By changing the fuel source, I think what they're trying to do is work around that. You could actually have ships that are operating at maximum speed and have less emissions. So you can get probably a premium price on shipping because you have a green shipping source. That must be the logic behind it. Whether it plays out in the marketplace or not, who knows? Are you willing to wait an extra day to get your plastic thingamabob from China? Maybe. Is it worth the extra money? Who knows?
Well, one of the interesting things is that eMethanol is produced from combining green hydrogen, which we've talked a lot about. And of course, Rosemary, our expert on that, and combining it with captured carbon dioxide. So we've talked about trying to find a market for carbon capture and all these different types of ways to clean the atmosphere. Maybe this is one of them, it sounds like.
It could be, right? The carbon reduction methods that are most talked about taking the carbon and taking the CO2 and burying it into rock formations where it will eventually crystallize. But maybe there's other alternatives, right? I just don't understand the chemistry of this. This is where it gets a little confusing. We're pulling hydrogen from water, we're ripping carbon from the air, and we're making these molecules, which are pretty complex hydrocarbons, which we must be able to do somehow. It just seems like there's a lot of energy loss in that transfer. So you have to generate a lot of solar and wind to strip CO2 out of the carbon out of the atmosphere. It takes a bunch of energy, and it also takes a good bit of energy to strip hydrogen from water. So there's a good bit of electricity generated that goes into doing that. That's where there is a cost associated with that. I think there's an assumption like solar is free. Solar is not free. Wind is not free either. There is a cost to create these molecules. Question is whether it's worth it or not. And I think Rosemary's been saying lately, maybe I'm rubbing off on it a little bit, which is it's okay. Let them try it. If it works, great. If it doesn't work, well, it's their own investment money. So be it. Maybe we ought to try a couple of different things. That's probably the right approach. Try it and see how it goes.
So what's your gut feeling? You feel like it's, if I'm hearing you correctly, it sounds like you think it's going to be too lossy and it's just going to be difficult to make it financially viable. Is that where you're at right now with this?
Right. Without external forces playing into it, maybe carbon taxes are playing into this. Maybe there's some incentive money in different parts of the world to do this kind of technology or making eMethanol. Maybe there's incentives to do it. So some accountants, a room full of accountants or somewhere, calculating if this is a plus project or a negative, and it must be positive for two big companies, Ørsted and Maersk, to get involved with it. So somewhere they've done the economics. It looks like it's a positive. We'll just have to see how it plays out, though, because so many things are changing right now. Who knows?
So, Rosemary, does this eMethanol solution, does that sound like a good place to utilize the carbon capture, which we talked about as maybe there isn't a really good market for the carbon dioxide that we're pulling out of the atmosphere? Is this maybe a good spot for it, or do you think this is going to be still too difficult for them to make this make sense financially?
I think there is no real good spot for carbon dioxide that's pulled out of the atmosphere today, because it's incredibly expensive and it's energy intensive, and we still have a lot of other much easier decarbonization options still on the table. So I'm a fan of carbon capture and storage, especially, including direct air capture, but more that I, want to see the technology matured so that by the time that, we get to 2030, 2040, and we've done the really easy decarbonization things like, just first of all, stopping to put more carbon dioxide in the atmosphere, then we'll have the technology available to start pulling it out and storing. But the interesting thing about using it then for fuel is it goes back into the atmosphere then, right? So you pull it out, you rearrange the molecules. So methanol is CH3OH. So there's some carbon, some oxygen that comes from carbon dioxide, and there's some hydrogen that we're going to get from water, plus a lot of power in both cases. So yeah, you basically rearrange these molecules by adding a whole lot of power to them that you can't ever get back. That's just lost due to the laws of thermodynamics. Then you use the methanol. Methanol is just a type of alcohol, so you can burn it and use it as a fuel. When you burn methanol, the carbon in the methanol reacts with oxygen, and then you've got carbon dioxide again. So it's, it's another use. They say it reduces the emissions intensity of the fuel rather than it being a zero emissions fuel. So if you pull it from the atmosphere, the carbon dioxide, and it ends up back in the atmosphere, then overall your net effect is zero in terms of carbon dioxide. but not in terms of the amount of power that was added. So if there's something you could do with that power that would prevent carbon dioxide from being emitted from burning fossil fuels, then that will give you a much better, carbon dioxide balance sheet overall. So that's why I'm not really in favor of this as a carbon dioxide removal project, but I am in favor of it as a technology development project, because eventually, we're going to need to be doing the really hard stuff like pulling CO2 out of the atmosphere.
Why do you know that CH3OH? Why do you know that? That's scary.
I just made a video. I better do my weekly shameless plug for
here
YouTube.
comes the plug.
It's still in production, but I have just interviewed, actually I did the interview ages ago last year, Dr. Jessica Allen from the University of Newcastle, who works with all kinds of carbon capture and use technologies. So we made a video about all the different ways that you can use carbon dioxide for things. And yeah, methanol was one of the more interesting ones. You can do other stuff with it too. You can make plastic eventually from methanol, and then that CO2 wouldn't end up in the atmosphere. It's locked away forever in plastic. We can, shove it all in the Great Pacific Garbage Patch and feel really good about ourselves for having improved the environment. So yeah, there's a trade-offs to be made all around when it comes to carbon capture.
Well, moving on, Sun Cable, which is a huge project backed by billionaire Mike Cannon-Brookes, who is the founder of Atlassian and others. They've gotten a big round of funding, a $210 million Series B round. Rosemary, tell us a little bit about this project. And obviously, they have a lot of backing. It's very ambitious. So, Rosemary, what are they aiming to do with this Sun Cable project?
Yeah, so it's a project. It's very divisive, actually. I'm a big fan because it's so audacious and just such a big big dream. And a lot of other people think that it's ridiculous and it's unplausible that it'll ever work. But it's basically a really common idea that everybody has had when they, think about the energy transition as a whole. You've got some really sunny places on Earth, and it's not normally where people are mostly living, in these really, really sunny places. And then, you have dense populations that either are located, somewhere where it's just geographically not really good renewable resources, or the population density is just so high that you can't fit in enough renewable energy to support the population. So in this case, they're aiming to put a huge wind farm, a huge solar farm in northern Australia. So in the desert there, lots of sun, not that many people living there. There is, it's near to Darwin, which is the capital of the Northern Territory, but it's a relatively small population. They're going to put a 20 gigawatt solar farm in there. So at least when it was first announced, that was going to be the biggest in the world. But, there's a lot of people vying for that title now. So I'm not sure if it still will be. Then they're going to connect it by a subsea cable all the way to Singapore, which is like 3,000 kilometers away. It's going via Indonesia, so it'll make a landfall there. And then into Singapore, where it's supposed to supply up to 20% of Singapore's electricity needs, via this really long subsea cable. So that will definitely be the longest subsea cable in the world. When and if they manage to get there. And at the moment last time I checked in, they're still in the seafloor exploration phase. And I have been watching pretty closely the project, and I have noticed that if you look at the number of kilometers that this cable is supposed to reach, it is gradually creeping upwards, that number, as they find out, there's like a really deep trench here, or this area, I don't know, has some other issue. So that's the kind of problem that they're solving at the moment. So yeah, it's one way to get solar power from a sunny place into electricity in a place where people live. And I mean, if we see them succeed, then it's going to open up possibilities all over. Like you can imagine connecting a solar farm in Africa in the summer to Europe's dense population in the wintertime, when they have a lot of energy needs. And, I'm sure you can think of many more examples where if you can get a several thousand kilometer long subsea cable, then you could connect up all sorts of areas to good renewable resources.
Alan, how does the length of that cable strike you? Does that seem like a pretty risky thing, a difficult engineering challenge, all the above? What's your take on it?
I think it's all the above right now. You're talking about 1,800 miles. I think I translated that right. 1,800 miles. That's from like Boston, Massachusetts to roughly Dallas or so, somewhere in there. That's a long way to run a cable. And if you have one in that in that cable link, you have to start over. So that's a very risky venture. And with $200 million in a Series B, it seems like they would have to have a Series C and D to get more investment money to do this. I don't know what the final cost of the project is, but my gut feels like we're talking about $500 million, maybe a little bit more, to get this project to completion. Because you have to build a solar farm, right, Rosemary? You have to build a solar farm. You have to put the cable in. You have to connect everything up, and then hope that it works and lasts a long time. So it seems like a pretty risky investment without a whole bunch of engineering work going into it. Rosemary, has anybody laid a cable across that water before? Is it uncharted territory?
No. There's another subsea cable project ongoing at the moment in Australia to connect Tasmania to the mainland Australia. So, Tasmania is the island that people forget off the bottom of Australia. And yeah, it's called the Marinus Link. And there's already there is already a cable there. I think it's called the Bass Link or something. Because Tasmania has so much hydropower and not a very big population. So, that's obviously very valuable because it's dispatchable, renewable energy. And if they can get that into the main electricity grid on the east coast of Australia, then that's potentially very valuable. And yeah, that project is struggling a little bit with financing. That's the impression that I get. And I know that one of their big issues is that the existing subsea cable connecting, Tasmania to Victoria, it's not 100% reliable. And that's one of the problems that you can imagine. If Singapore is going to start getting 20% of its electricity from this cable, what happens if the cable goes out and, it takes months to repair it? That's hard. So the Marinus Link cable, they're planning to make two in parallel. And I don't think that they're following the exact same path because, obviously to get the redundancy, that's what you'd need. Whereas with Sun Cable, it's been a while since I looked into it and I really should, do a video on it or something. But I don't think that they're planning two separate, totally redundant cables. I can just imagine how much the cost would balloon out if they did that. But for sure, reliability is going to be a challenge for them.
Is it a high voltage DC system? I assume to go that far, to transmit power that far, you'd almost have to go to a high voltage DC system to do it. Okay. That would make sense. But the Tasmania cable, is it also high voltage DC? That sounds like a much shorter route. Huh. Well, that's one of the advantages of sort of technology today is the high voltage DC can allow less losses and more stability, I think, in transmission of long distances. But again, it's another weak point in the system, or it could be a weak point in the system because it's just an electronic piece of equipment to transfer power. So as we know, with laptop computers and everything else electronic, that's the part that's going to fail first. So again, it's redundancy, right? It's a redundancy. And you're right. If you have 20% of your electrical power coming in from Australia and a single component fails and you lose 20%, that could be really a long-term problem. So it just adds to the cost trying to make the system more reliable, which I assume they're going to do.
Yeah, I know that it's so easy to store electricity, but I guess it does share a lot of things in common with if you're relying on Russia for like 2/3 of your domestic heating needs or something. You need storage, and you need to think about what you're going to do if that relationship really sours. But yeah, I think that, I don't know, it feels more immediate with electricity because I guess, when the current stops, the lights go out and, I don't know. It feels more urgent for electricity than it does for gas. So yeah, I think people will be pretty focused on that.
Well, moving on, let's talk about this interesting new small wind turbine design, which actually flaps. It's by Catrick Technologies, and they come in these little sort of like hexagon pods that they look like a ducted fan, Alan. They look like they're straight out of like the aerospace industry. But I guess they flap. Rosemary, how was this thing converting wind into electricity here?
I assume the same way that, not that birds are making electricity with their wings, but, I think it's working. The aerodynamics are roughly the same as a bird's wing. And I mean, it is kind of like a niche little field of engineering trying to make a flapping wing aeroplane. And they have succeeded. They usually find like the tiniest pilot that they can, but there do exist aeroplanes that can fly with a human in them, and they fly by flapping their wings instead of by aerodynamic lift. And it's just so difficult to do because lift force is practically like it's as close to magic as you get with engineering. Like the size of the forces involved in lift are immense compared to the surface areas and the wind speeds. It's a reason why a normal, horizontal axis wind turbine, or even some of the vertical axis ones as well, the ones that use lift forces generate much more power, much more efficiently than ones that use drag forces, and flapping wings are always going to be using drag force. So, I'm pretty surprised to see that you would do that. There are other it's not the first flapping wing wind turbine that I've ever seen. There's another one that claims to be inspired by hummingbirds, and makes very nice Kickstarter video, which I'm sure this one does too. But flapping wing, it's a lot of moving parts, really high stresses, changing constantly. When I look at it immediately, I see low efficiency. They say that they're aiming for 25%, which you can easily exceed that with even a drag-based vertical axis wind turbine, like the kind that's in, like ventilation systems or meteorological stations. Those are very cheap, simple, robust, and can get you the same or a little bit higher efficiency. So I don't know. It's kind of like they've taken a few different projects that haven't worked out and combined them to make another project that isn't going to work out, I think. But makes a nice Kickstarter video. So I guess that's probably their intention.
Well, I was just driving actually, not across the country, but I got 10 hours into the middle of the US, and on my drive, I noticed some vertical axis wind turbines on top of an otherwise pedestrian building. I don't know if it was a government building or just like a shopping mall or something, but it was really surprising to see them out there because this wasn't, I don't know, it was kind of in the middle of nowhere. I'm not sure where it was, but I remember seeing them and I'm like, like they're not that mainstream where you would just see them somewhere in middle America. But it does seem like they were turning. And so it seems like they're trickling out there somewhere. So I don't know, Alan, do you see a market for something like this potentially?
Well, there's been this large discussion about small wind turbines and things you can mount to the roof or top of buildings that could generate some electricity. I just don't think it generates enough electricity to matter. Plus, it's just going to be this maintenance piece that requires an engineer or highly trained mechanic to go up and fix all the time. Or I don't know how you don't have that situation. Anything that moves, shakes, vibrates, it's going to have failure modes. It's going to wear out over time. And then this Catrick approach also is the quote unquote wind turbines are really close to the ground where there's low wind speeds. You need to get up in the air where there's some wind. So that doesn't make a lot of sense. I think the intent is right and the approach is right. Just a question of whether the economics work out. And if it pays for itself, yeah, absolutely, people will buy them. If it has to have a little bit of a proven track record, though, and I think that's where the industry will come into play. Of does it work? Does it pay for itself? What's the return on investment? If it's less than 3 years, then you'll have a lot of people at their counter wanting to buy this. If it takes 5 to 10 years, you just won't see it, and that's where a company will be great or will just kind of meander along. It's because that return on investment isn't high enough. That's this yet to be determined. And Rosemary, maybe they have some engineering technology we haven't heard of, or an approach that we haven't thought of before. It's totally possible. Maybe it will work.
Yeah. but some of it, I think it will work. I'm sure. I mean, you and I could knock something up similar in a week or two that would generate electricity. But I mean, if you have a look at it, they've got this blade. It's like a bird wing, and it's flapping like this, and it's attached by this tiny shaft. Yeah. I mean, there's going to be immense forces on that shaft. It's going to break in fatigue. All their videos just show computer renderings of it working, even though they have some still photos of a real system. It's all red flags to me. And when it's just, it's just clearly a design that's going to have maintenance issues, but they haven't addressed any of that or shown, any, you would want to see thousands of hours of operation of something like this before you bought one, because it can nearly guarantee that the first systems that they install are going to be broken in a couple of months. And, they can iron that sort of stuff out, but I just don't believe that the potential is there compared to a regular, those Savonius wind turbines that are just like, basically they just, use cups and the wind just pushes them around. They're so cheap and robust. And if all you want is 25% efficiency to shove close to the ground, then do it that way. I just can't see this ever beating that. And they're not even aiming to beat it in terms of efficiency.
Well, and also the way they're stacked up and like they're sitting on top of buildings, it seems like they're put in the exact places you could just put solar panels too. So it's not clear to me how this would be a better solution, better application than, very cheap, proven solar panels.
Yeah, and that's what Paul Geip would always say in small wind applications. The obvious answer is solar, because all you have to do is wipe the bird poop off it, and that's your maintenance for the year. That does make sense versus worrying about bearings and things that rotate. Anything mechanically that rotates going to require maintenance, where solar panels don't. And solar panels are, at least still today, relatively inexpensive. So on buildings and houses, it makes sense to do solar. On larger projects, wind is going to be, I think, the answer.
Well, and in DC, we have a increasing rat problem, and I think someone should invest in a way to convert rats into electricity. Maybe like they wear like little socks, just like you scoot around your carpet and you get static electricity.
Little rat wheels are spinning on the street.
We need something. We have a lot of rat power here. It's untapped.
Ben, you need a Kickstarter campaign.
Growing daily.
Get funding.
They're robust creatures. They will be here for the long haul. Let's put them to work.
Exactly.
Well, moving on, let's do some predictions. So obviously one of the big things in the news cycle right now is inflation, which is only getting worse now that the war on Ukraine is continuing to rage on, sadly. Alan, we'll start with you. What do you see inflation going to later this year, or even just in the very near future in 2022?
Right now, inflation's about 8%. And that is historical high that's like a 40-year high, at least in the United States. It's not for some countries. In the United States, that's historically a high number. If the war in Ukraine drags on and we get into an oil dispute with Russia, which we're inevitably going to have happen, then the Biden administration will have no power to control inflation except through the Federal Reserve, that they'll start raising interest rates, trying to slow down the economy and making it harder to do everything, which temporarily will bump up inflation even more. So they're going to start making economics hurt. So there's a reasonable chance that we get to a 9-10% inflation rate, which would just be incredible. That's not something that happened in my lifetime. But the other half is that the way they would drive it down is to restrict the money flowing in the economy, start driving money out, actually physically pulling money out of the economy to stop the overheating. But it just makes life harder because interest rates will rise. So it's a very cyclical problem that has a 3 to 5 year lifespan before it settles out. And the Federal Reserve of the United States has been unwilling to make that happen in the midst of this war in the Ukraine, because they realize the amount of pain it's going to put onto the average consumer in the United States and around the world. It's going to affect, the United States is a big economic power. So anything that happens internally to the United States, other countries are affected. So it's like the Federal Reserve can say, well, you know what, United States citizens can handle it for 5 years. We're just going to go ahead and pull the trigger on this. That won't be the reaction. There'd be a lot of pushback from the world on it too. So there's a very complex mix of inputs into this economic equation and likely outcomes of it. What it means for the energy equation is really hard to say. We saw the other day where President Trump is lambasting wind turbines, which is just his pastime at this point. But whatever. I think we do need to think about increasing oil production in the United States temporarily to help stabilize at least energy prices. I think that's going to have to happen in Europe also. Whether they do it or not, who knows? But there's too many variables at play at the moment to be very predictive. That's the scary part. 3 years ago, world economy pretty predictive. Things were stable. Now everything's in chaos, and we don't know what's going to happen. The Iranians shot a missile into Iraq, into the U.S. One of the U.S. consulates there in Iraq yesterday. That's really causing a lot of consternation in Washington, D.C., like it probably should. The American population doesn't seem to realize that too much because it was downplayed. But that also adds putting Mideast oil into play as an additional pinch point is going to cause a lot of problems in the United States, including inflation. So I give it 50-50 chance to cross 10%. Hopefully it doesn't stay there long, but we got to settle things down in the world here pretty quickly. Otherwise, some of our green energy ambitions are going to get set aside for 5 to 10 years. And that's not where we need to go.
Rosemary, what do you think about inflation globally?
Yeah, it's actually not as high in Australia yet. And I'm no economist. I actually really struggle to understand why Australia can have ours are around, maybe 3%. Inflation's around 3% in Australia at the moment, and it's high in the US. It's high in New Zealand. It's I don't get it, but we are still starting to feel the effect, and definitely inflation is higher than wage growth. So that's probably the main balance that people will notice. If inflation is higher, then your cost of living feels like it's going up. And so I think it definitely it has the capability or the possibility to negatively affect the speed of the energy transition, because renewable energy projects are very, very capital intensive. So you need to spend all your money up front. If you're putting in a wind farm, you buy the wind turbines, or a solar farm, you buy your solar panels, and then you just leave them there. You don't need to keep on paying for fuel. And in terms of solar panels, you don't even need to pay for maintenance much ongoing. And you contrast that to if you're putting in, a coal power plant or a gas power plant, then that's the costs are more spread over the lifetime. So the interest rate that you can borrow capital to, install it isn't as important. So that's a potential handbrake. But I think that there are also some effects that will be the opposite. And I actually think that overall we're going to see that this new inflationary environment might actually help speed the transition, speed up a few kind of pinch points or bottlenecks that we've got. Yeah. So in a couple of ways, because I think that there's been some really artificial constraints on the energy transition recently. One of them is transmission. We need more transmission lines. That's, the number one barrier to installing more renewable energy projects, not people not having access to capital. There are so many investors with so much money that they want to spend on wind and solar farms, but they can't guarantee that they're going to be able to actually connect it to a grid and start making money. And I think if people start to worry, like your average person starts to worry about their electricity price a bit more, then they might be more tolerant of having a power line put in near to their home than they have been. So we might see, some lessening of community resistance to transmission. It's a hope more than a prediction. It's a possibility. And then secondly, it's my favorite topic that I always like to come to is load flexibility. There are some flexible tariffs that a household can go on and take advantage of, the difference in power prices. The wholesale electricity market, the prices vary so much. At least in Texas they do, in Australia they do, and I don't know every electricity market in America. I know they're not all set up like that. But you see really high prices. In Australia, it'll be up to $15,000 when the system is constrained, when there's, more demand than there is supply available. And you can get down to zero or negative prices when there's opposite, when there's, too much wind and solar usually. But your average household doesn't see anything from that. Even your average small, medium business doesn't see any of that effect. There's a lot of value on the table there to, if you can have a retailer that's going to pass on some of that difference to the household, there's a lot of effect that you can have on the electricity market, to lower households and businesses' power bills, and at the same time make the whole system more robust. So the eventual effect of that will be that we need less storage for the same amount of renewables in the system. So I'm hopeful that, this extra focus on prices is going to lead people to think a little bit more creatively about how we can take advantage of the very low cost of renewables when you can use them, they are low cost. And at the moment we can't use as much as we would if we had more transmission and more flexibility in the way that we use the electricity.
A barrier to entry here in terms of there's certain industries which would be hard to transfer over to electricity, even homes. So there's a lot of homes in the United States are still using natural gas or oil to keep their homes warm in the wintertime. So that's not an easy transition to make. If you're talking about retrofitting hundreds of thousands, millions of homes and businesses to electricity, that's an impediment that will not happen in the next couple of years. I agree with you. It can make sense to maybe stabilize the electricity market by providing more renewable sources onto that. But the receiving end is not ready for it. I mean, we can build as much as we want, right? But we don't have the ability to actually use it. And the discussion in my state, Massachusetts, is, well, how are we going to transfer all these homes from essentially oil to electricity? How do you do that? How do you do that quickly? You have to get into everybody's home and then retrofit the thing. And that's almost impossible. That seems like more like a generational switchover than it is a 5-year plan. And until we recognize that we can't, if we create excess capacity, it's going to drive the energy prices down electricity wise, and there'll be some beneficiaries in society that will greatly accept it, like aluminum smelters, and people use a lot of massive amounts of electricity. But for the average homeowner, I think it's going to be a problem that you have to incentivize them to switch over. And it's not going to be cheap. It's going to be $20,000 I think, to do that on average.
But don't you think that incentive will be there if we get a widening gap between the cost of gas and the cost of electricity? I mean, in Australia already, it's cheaper to heat your home with a heat pump than it is with gas. Right. And I know that that's not the case in a lot of other places. But if you look at Europe, I've seen some charts of the rollout rate of heat pumps, and it's been increasing recently. Right. But imagine if it was cheaper, if your boiler broke and you needed to replace it, and you realize that now it's going to be cheaper for you over even, like a short number of years to put in a heat pump, then I think that would, accelerate the rate that people voluntarily change over. Don't you think?
You have to have return on investment. All homeowners are investors. That's what a home is in the United States. A home is an investment. And if you're going to put in a newer technology like a heat pump, which involves drilling holes into the earth and putting tubes down in, and you're going to spend $5,000, $10,000 doing it. And it's not necessarily.
Yeah, it depends where you are, but you can have air source heat pumps over most of the US.
You sure?
Yeah, but we're saying the same. Yeah. I mean, they've got them in like Norway and Sweden and stuff.
Plus the magic that makes them function. Remember,
plus the magic.
Yeah.
But I mean, we're saying the same thing. I'm saying as the cost of gas goes up and the cost of renewables goes down, then you're going to see the business case for installing a heat pump get to the point where it just is a business case for a household that makes sense sooner and sooner and sooner. The payback period will get less and less the bigger that gap gets. So I think it will help.
Yeah, I think in a newer community, it would make sense. In what exists in the vast majority of the Northeast of the United States, homes were built after World War II. They're like 1940s, 50s, 60s, into the 70s, a large portion of them. So those homes have a variety of heating methods, mostly oil. I think that's going to be a big impediment to having more electricity. Even, well, I can tell you it is right now. The real crux of the matter is that the proponents of wind and solar are doing a good job. But when it really hits the average consumer, the numbers don't work out. And that's where the pushback begins. So you have to solve both ends of the transmission equation. You have to be able to generate it, but you also have to be able to use it and use it instead of alternate energy sources like oil. Until you complete both sides of that grid equation, you're going to be stuck. So it doesn't matter which side is off. It just, there has to be an energy balance here. And you're also right about transmission lines. Transmission lines are not sexy. No one says, hey, let's put a transmission line in my backyard. They don't want them. And we're going to need more transmission lines and more high voltage transmission lines, which are not quiet, by the way. They hum all the time. That you're going to have acceptance of those. And that's going to take, like I say, it's going to take a generation of people to accept that. And I don't think it's going to be immediate. That saying, I don't think we should stop what we're doing. I think we need to continue with it, Rosemary. It's just a question of acceptance. You have to, was at O&M conference, ACP O&M conference last week, and this is stuck in the back of my head. You have to sell both sides of this thing. You can't just make an argument that the return on investment for an offshore wind farm is X without have some way of powering homes. Those have to go together. And we seem to be on one side of the equation right now because it sounds good in a press release. I don't know when we're going to use that power to power homes. That doesn't really power homes like we think. I mean, it runs lights and the laptops or whatever nonsense we have running. But in terms of like sort of the fundamentals of a home, a lot of people still have gas ranges. A lot of people still have gas heating. They'll also have to be converted. Not an easy problem to solve.
Well, next prediction, let's move on quickly here. Is this going to slow jobs growth, or is this going to really speed up the automation of the wind industry as everyone tries to, reduce costs and make up for some of the buying power that they lose with inflation? Rosemary, what do you got on this?
It's interesting, the idea about jobs. Like with new energy, you've got two things that people care about. One is that it's cheap, and two is that it makes a lot of jobs. And it's interesting because these things kind of are like inversely related to each other, right? If it's very cheap, then it's not going to need a lot of maintenance. And if it, doesn't need a lot of maintenance, then there's not going to be a lot of jobs. So it is really funny that, for the most part, you're trying to say, renewables are really, really cheap and great. But then you also want them to sound like they're going to make a lot of jobs. And the way that I look at this, is, I've been doing a bit of work on levelized cost of energy, and you can split that down into the components, like how much of the cost of energy, of the cost per kilowatt hour, how much of that comes from the capital cost, the equipment that you bought at the start, how much comes from finance, how much comes from fuel costs, and how much comes from maintenance and operations. Those are the main components. I don't think I forgot one. And so if you look at like what proportion of the cost of energy from each different kind of technology, what proportion comes from operations and maintenance, then for me, that's like a good proxy for how many jobs does it create. I mean, I'm sure it's not perfect, but I think that's decent. If you're spending more on maintenance, then you're probably spending more paying people to do the maintenance. And so solar has by far the lowest maintenance costs, right? You put them out in a field or on your roof, and you barely look at them again. Like, you might clean them once a year, maybe more if you're in a very dusty environment. So yeah, solar is cheap, partly because you don't need to pay people to look after it a lot after you're done installing it. But wind energy has really similar maintenance costs to like a gas power plant, for example. So, you got things spinning around, and when things move, they degrade, they need maintenance, they need to be, lubed, and components need to be changed out, and you need to check the torque of bolts and stuff because things vibrate. So there's not a huge difference between, jobs for wind farms versus for, other kinds of power plants. And I don't know if I see any more. There is a lot of scope for automation in maintenance and predictive maintenance in all kinds of power generation. And I don't see that it's so different for wind turbines than for other kinds of power plants. So I don't see a really big difference
of wind turbine technicians into the States. And there's a lot of companies trying to hire people. So that at least this year and maybe next year, there's going to be a lot of new entries into the wind turbine repair market, just because there's so many wind turbines that are getting of that age where they're going to need a lot more maintenance, particularly on the blades. So I think that the job market wise could be really good. You see a flood of technicians and hiring announcements on LinkedIn. This is the time of year where everybody's running to go get their job for the summertime. I think that will continue to happen because Rosemary's right. Anything that rotates, particularly wind turbine blades, just get abused. There's no way else to describe it. They're getting abused, and they do take a good bit of work to keep up and running. So you're going to see that part of the industry not really slow down anytime soon. We haven't never fixed the wind turbine blade leading edge erosion problem, to at least to my satisfaction, and probably to the operator's satisfaction from what I can hear. So there will be a decent number of jobs, but Rosemary's right. I mean, the way that the industry's going is they want to eliminate people because that lowers costs. That's where it'll go.
You know, it's interesting though, because we're talking about the huge size of the challenge. If we're going to start electrifying people's houses, we'll have to, change boilers to heat pumps and gas stoves to induction. Super expensive. So many jobs, so many jobs needed to do all that changeover. So yeah, it's almost like you can always find a positive from a negative if you include both cost and jobs, and you just want one of the two to be higher. I mean, it usually is.
This is part of the discussion in the United States lately. Why is inflation so high? Is one of the reasons, and the Biden administration is pushing back on this actively, particularly over the last weekend, is the federal government has pumped trillions of dollars into the economy. Well, that devalues the currency. And the little discussion point that's happening is, well, if you're going to put $10 trillion into the economy over the last couple of years, maybe you should have gotten something out of it, like converting to electricity. That's a discussion.
That's
where did all the money go?
Idea.
Right? Well, yeah, where did all the money go? Now, there's a lot of places where the money went, right? And I it just gets difficult to comprehend the massive amounts of spending that happened in the last few years. And if you're an average citizen walking the streets, you don't see it. You didn't see where it went. You didn't see it benefit your day-to-day life. So you feel like there's a lot of games being played here to elect politicians and not help the average consumer. And that's going to have consequences. I tell you, that's going to have consequences in November of this year, for sure.
Last question. Sanctions. Are they going to continue to make everything worse in the long term? Or are there going to be maybe some positive outcomes like, hey, we're going to have to start maybe being more reliant on local technologies or more local employment or, I don't know, new technology in general? Alan, what's your take? I'll start with you.
Sanctions are not someplace you want to go, just because it creates economic imbalances. In some places, it makes sense if dumping is going on, and the constant complaint from China is dumping solar cells, China is dumping steel, China is going to dump airplanes, China is dumping wind turbines into Europe and the Americas. So we need to put some restrictions on that. Otherwise, we're going to destroy our industry. Okay, and I think that has some justification. I think that makes sense from a national security standpoint. Like the sanctions that are going on with Russia will not, you hopefully will not go on so much longer. But at some point, you want to use sanctions to isolate a country, to make them reconsider the decisions they have made, and then to draw back and try to come to some stance where both sides feel like they've won something, whatever that winning looks like. But the sanctions, you don't want to keep on super long. When I say super long, 2, 3, 4 years, like if you want to, like we've done with some other countries, just because it doesn't always have the effect in which you dream that it does, right? It has a very engineering approach. Well, if I push this button, then this reaction will happen. That never works, right? I push that button and there's a myriad of outcomes, probably a variety of outcomes, each with their own probability. And I don't have any idea where I'm going. So it's not just sanctions by themselves, because sanctions by themselves, I think, are too easy for governments to implement when the consequences are way too wide. It has to take sort of a team approach and a constant monitoring. If you're going to do sanctions, you have to constantly monitor it to make sure it's having the effect that you want. I feel like when America applies sanctions, they apply sanctions and then they get busy watching NBA basketball games or NFL football or something for 2 years, then come to wake up like, oh man, the sanctions didn't do what we wanted to. Surprise, right? It is much more involved. That's why I get scared when governments, doesn't matter who it is calling for sanctions. Sanctions over 6 months, cool. Sanctions for 5 years, not so much.
This is a topic I really don't. I don't know. I don't know what the answer is good. You can definitely see why people want to do sanctions, and I know when I was living in Europe, I would sometimes go to like the BMW museum or the VW museum, and you go back and you have a look at their history. And in Germany, they're all very, very focused on what were we doing during the war, and most of those companies were supplying the Nazis. A lot of them using forced labor from concentration camps or prisoners of war. And so you can, with hindsight, say, okay, these companies shouldn't have been involved in those activities. Probably harder to say when, that's your own country that you're supporting during the war. So you can imagine, in 50 years' time, looking back and whatever companies or countries are benefiting from these relationships with Russia, if it goes on to, turn into a big conflict, then and assuming, that that they come out on the wrong side of history, you can see how that's gonna look in the future. It's gonna look bad, and so you shouldn't do it. You shouldn't, continue to profit off this misery. Basically, I think is that you're either giving them money to to do bad things, or you're profiting from them. Which is sort of the same. But on the other hand, if it doesn't turn out into a full-blown thing, there's plenty of examples of, sanctions in the past where you're like, well, did this really achieve any benefit for humanity, or did it just make ordinary citizens suffer? So I think there's definitely like both sides to the story here. And I don't know. I feel like this is above my pay grade, more of a political commentator's, topic to comment on. I'll just say, it's very complicated.
Rosemary, I think the thing to remember here is energy is national security. They're intimately linked. And to think about energy not being related to national security is a falsehood, right? And that's where we have to realize that when we talk about energy infrastructure, when we talk about making changes to the energy network, do we talk about our sources of electricity or power? Those have really serious consequences way beyond whether we can, use our oven or not. It has more to do with the stability of nations, the growth of nations, and in some level, staying out of war. And that's where I think the discussions really need to be had. We seem to be having a lot of sort of low-level discussions that don't put the big picture in perspective here. And maybe it's just part of the natural ebb and flow, particularly in the United States, of the discord that's happening on the political parties, that we're all just infighting. They're just infighting on both sides all the time. Who's thinking about the big picture right now? I don't know. That's usually the executive office of the president of the United States, and that sort of group is sort of focused on the long-term effects for the country. I don't feel like that's happening right now. I should feel like that's happening. I don't feel like that's happening. And that's worrisome, not only for America. I think you could apply that same concern to many countries around the world right now, unfortunately.
Yeah, no, I think you're right. And I think you got to distinguish as well between the sanctions and energy security. I don't think energy security and self-sufficiency, I don't think that's a complicated question. I think that every country would benefit from, being as energy independent as possible. And I think if you look back through history, there are at least quite a few conflicts that have arisen or escalated or been affected because of energy security. So that's an easy question. Yes, everybody should be moving towards self-sufficiency with energy. And I think everybody is aware that these days that means more renewables for most countries, and figuring out all that. Yeah, there's challenges along the way. It won't be easy or fast, but when there's a threat of war, things that were previously slow do tend to speed up a lot. So I see definitely tendency towards that direction from many countries.
But can we have too much independence, like we saw with Texas, weren't connected to the rest of the U.S. power grid, and they had an issue and they got shut down and things were chaos, right? I mean, probably hard to figure out what the balance is where if a country has major issues, like their cable goes out and they lose 20% of their power, like in the Singapore proposal, is there a neighbor that can help them, or are they stuck? These are very, like you said, very complicated questions that no one probably has answers to, but I'm sure a lot of people are thinking about.
Yeah, I guess the right term there is energy security rather than independence, because, it's not just a matter of only using your own, it's a matter of it being secure. So either, and for some countries, it's easy to have both, like Australia or the US. And for some countries like Singapore, it's not so easy to, make all your own energy and be secure. So it'll be horses for courses, different solution for every country based on their specific circumstances.
Well, that's going to do it for this week's episode of the Uptime Wind Energy Podcast. Thanks so much for listening. Be sure to subscribe on iTunes, Spotify, YouTube, Stitcher, wherever you listen. Definitely subscribe to Uptime Tech News, which you'll find in the show notes or description below, as well as Rosemary's YouTube channel, which you'll also find. She continues to put out great content, so definitely give her a subscribe. So thanks again for listening. We'll see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.